All right, this is section 7.2, hypothesis testing for the mean where sigma is known. We're going to work through some examples here. I've got 3 examples I want to go through and show you how to work these problems. Look, guys, we're transitioning chapter 6, chapter 7, chapter 8, chapter 9. We're transitioning to basically a bunch of word problems. So look, anytime you have word problems, the first thing I want you to go through is go through, after you read the problem, figure out all the numbers, okay? So first thing we're going to do is read the problem. A salon claims that its mean haircut time is less than 13 minutes. You test this with a random sample of 32 men's haircuts with a sample mean 12.9 minutes. Assume the population standard deviation is 0.19 minutes. Is there enough evidence to support the claim of alpha 0.01? Use p-value. Okay? So, what's going on here? What in the world are we going to do? Well, first thing I want you to do is label all your numbers. So, first number I see is 13 minutes. What does 13 minutes have to do with? Okay, there's a claim being made. We need to figure out what the claim is, all right? Its mean is less than 13 minutes. What do I use for mean? I use mu. So the claim, I'm going to write this out. The claim is mu less than 13 minutes. Mu less than 13 minutes. Doesn't say less than or equal to. It's less than 13 minutes. Now that's my claim. Is my claim a ho or a ha? Well, I don't see an equal sign, so this has got to be the ha. If this is the ha, what's the opposite? What's the complement? The complement of mu less than 13 is mu greater than or equal to 13. Okay, so big part of your first test is labeling your ho and your ha. So we got that down and we know what the claim is, which one the claim is. Now, the next part, you test this with a random sample of 32. So 32, that's our random sample. That's how many there are. That's n equal to 32. Okay? In this sample, we're given a sample mean of 12.9. Sample mean is x bar. You have to know the players. That's x bar. It's not the population mean. It's the sample mean, 12.9. Assume the population standard deviation is 0.19. Okay, 0.19, that's population standard deviation. As soon as I see the word population, I should be thinking sigma. Now, if you remember this section, okay, what did we start off by knowing? We knew that sigma was known, so I know I'm using sigma in this section. But how do I know whenever all the problems are mixed together? It will say population. That's the key word I'm looking for, population standard deviation. If it only says standard deviation and nothing else, we have to assume that's S, okay? Is there enough evidence to support the claim? Now, why do we use support the claim instead of reject the claim? The claim is the ha, and all you can do with the ha is support the claim. All you can do with the ho is reject the ho, okay? So that's why we use the word support the claim at alpha 0.01. So they give you this alpha 0.01 here. All right. So before we start this test, we have to know that it satisfies the central limit theorem. Central limit theorem, either n greater than or equal to 30, or the population is normally distributed. Well, guess what? It doesn't say anything in here about the population. So we don't know if it is or if it isn't. It could be, but we don't know. But we do know that n is greater than 30. So what I'm going to do is I'm going to put CLT right there. That tells me n's greater than or equal to 30. Okay, therefore we can use the z-test. What does the z-test say to do? I need to get the standardized test statistic. That's z. That's the z-test. X bar minus mu over sigma divided by the square root of n. Who are the players? Who are my players here? X bar right here, 12.9 minus mu. What was mu? The claim is that it's less than 13 minutes. So if it's 13 or greater, right, that's the hoe, and we're saying less than 13, so we go to that extreme value of 13 for our mu. Now I divide by sigma, 0.19, divided by the square root of n, square root of 32. I'll give you a chance to type this in your calculator, okay? And when you type this in your calculator, to get negative 2.98. Negative 2.98. All right, since P is less than, all right, before I jump into that, let's talk about trying to calculate the p-value. Z equals negative 2.98. Okay, what's in the middle? Zero's in the middle. Where are we? We're on the left side, so we're over here at negative 2.98. So what type of test is this? The type of test is determined by the HA. The HA says less than, so that's a left-tailed test. Left-tailed test. All right? It's a left-tailed test. So that means I shade to the left. So all I need to do is go look up the z-score for negative 2.98. Go look it up, and you get a p-value equal to 0.0014. 0014. Now, alpha here, alpha was 0.0100, right? That's alpha. So alpha is bigger or smaller? Alpha here is actually bigger. 0.01 is bigger than 0.0014. So what does that mean? Is that a big or a small p? That's a small p. So since p is less than alpha, we reject the hoe. Reject the hoe. Okay? So what does that mean in English? There is, since I rejected the hoe, there is enough evidence at level of significance alpha equal to 0.01 to support the claim. What was the claim? That the mean men's haircut time is less than 13 minutes. So there is enough evidence to support that it's less than 13 minutes. All right, you went out and you sampled 32 people and you got an average of 12.9. Seems pretty close, but you can now statistically say that, with a 1% level of significance, that the evidence shows that you can get out of there in less than 13 minutes, which is not bad for a haircut. Okay, so why did we use the word is here? I used the word is since I rejected the hoe. Okay, I used the word is because I rejected the hoe. Say I had said, something like fail to reject the hoe. What would I said here? I would have said instead is not. That's what I would have said. Okay? See the difference? And then go up here. Why did I use the word support here? Because my claim was the ha. Had my claim been the ho, I would have used the word reject here. okay? So if the claim is the ho, the only thing I can do with the ho is reject it. If the claim is the ha, the only thing I can do with the ha is support it. So those are the words that will change from problem to problem, okay? So next problem. The mean indoor temperature at night in the winter is 68.3 Fahrenheit. You think that's wrong. That's what you're claiming. You think it's bull. Okay? Give a random sample. So if you're given some random sample, you go out and you ask 25 neighbors, what is your average temperature at night? And they come up and they give you a number. You go and you run the statistics. You get the average X bar and you know the population standard deviation, 3.5. Your question is there enough evidence to support this claim at 0.05? Okay? So we got to write it out. Mean, okay? So first number I see is 68.3. That's talking about the mean temperature. So what do I say here? I'm making the claim that it's wrong. So what does that mean? The mean is not equal to 68.3. That's my claim. I don't know what it is, but I'm saying, by golly, it's not 68.3. That's my claim. If that's the claim, okay, what's the opposite of the claim? What's the complement? It's mu equal to 68.3. So which one's the ho, which one's the ha? The ho has the equals. The ha is the opposite of the ho. There's no equals here. Okay? All right. Now, in order to use this, I have to know from the central limit theorem that n is greater than or equal to 30, or that the population is normal distributed. If I look here, I have my next number, n25. N is equal to 25. That's not greater than 30. Okay? Does it say anything about the population being normally distributed? No, it doesn't. So at this point, you would say not enough info to work the problem. Hey, isn't that pretty cool? That's really easy to do instead of doing all that other work, right? So all I got to say is not enough info to work the problem. So it's good to make sure you've got the keys to the Ferrari before you try to jump in that Ferrari, okay? So before you try to use a central limit theorem, make sure one of them's satisfied. Well, guess what, guys? That's in this scenario, but let's assume we do have a population that's normally distributed. That way we can work through the problem, okay? I just wanted to show you what it would be like if you ran into the scenario where neither one worked, all right? So assume that you do have a normally distributed population, then you're good to go with the CLT. So I know n is equal to 25. What's the next number? X bar, and then sigma, and then alpha. So it's just listed to you. It's pretty easy. X bar, 67.2, sigma, 3.5, and alpha, 0.05. Okay? So I want to calculate the standardized test statistic. Z equals X bar minus mu over sigma divided by the square root of n. You're going to write that 100 times, so it's going to be like second nature to you. X bar, 67.2, that's the sample mean. Subtract the mean, 68.3, over what? 3.5 divided by square root of n. What was n? 25. When I type this in my calculator, I should get negative 1.57. You should practice this. Okay. Now I need to go and draw my picture. What's in the middle? Zero's in the middle. What type of test do we have going on here? What type of test do we have going on here? Am I shading to the right or am I shading to the left? Okay, just because it's on the left side doesn't mean necessarily that I shade to the left or to the right. What type of test? The type of test is determined by the HA. What's the HA say? Mu not equal to 68.3. So that means mu could be bigger than 68.3 or less than 68.3. So this type of test, this is a two-tailed test. A two-tailed test. Okay? So look up the z-score, go find the probability, the p-value over here, which is half my p-value over here. That's 0.0582. That's 0.0582. Now 0.0582 is over there, then 0.0582 is over here too. So what is my total p-value? My total p-value is 2 times 0.0582, which is 0.1164. 0.1164. Okay, so what's going to happen here? Well, alpha was set to be 0.0500, right? So do I have a big P or a little p? Compared here, P is greater than alpha. If I got a big P, I fail to reject the hoe. Okay? So what does this mean in English? There is not. Why do I say is not? Because I failed to reject. There's not enough evidence. Your Honor, the prosecution did not bring forward enough evidence to solely convict Mr. Clark of the crime. Therefore, we must acquit. Correct? Right? Yeah, okay, all right. Sorry, I went on a little tangent there. So there is not enough evidence at the 5% level of significance. Now, level of significance is kind of a lot to write. So I like to just say alpha, okay? So if I just say, you can say this, or you can just say alpha 0.05, whichever one floats your goat, okay? 2, and then do I support or reject? Well, which one is the claim? The claim is the ha. So the only thing I can do with the ha is support. To support the claim. What's the claim? That the mean indoor temp at night during winter is different from 68.3 degrees Fahrenheit. Okay? Why do we say different? Because different is not equal to. Okay? So I'm just trying to use English there for you. All right, so we talked about this in the other video. We have one more example for this section. Okay? Researcher, right? Researcher claims the mean annual cost of raising a child less than 2 years old by a married family is $14,050 per year. So a little bit of money right there. So that's government statistics. So those are real statistics right there. I think this data was collected in 2016 year. Random sample 500 people. So you go out and you ask 500 people how much you spend on your kids if your kid's less than 2 years old. Okay? And it's married couples. The average amount of money was $13,795. Assume the population standard deviation of 2875. Well, at alpha 0.1, is there enough evidence to reject the claim? So the first two ones we did were like supporting the claim. So now we're rejecting the claim. So before we do anything, I already know the ho is the claim. Okay? So let's try and see if I can work through it. I got the ho and I got the ha. Okay, typically the ho comes first and then we write the ha. So researcher claims annual cost raising a kid is, okay, this is our number. Is means what? Is means equal. What is equal? The mean is equal. The mean is equal to 14,050. All right? That's my claim. Now, the opposite of being equal to that is not being equal. So, not being equal to 14,050. All right? So, that's how we set it up. Okay. I guess, what type of test is it? How do we find the test? We look at the ha, don't we? If it's not equal to, that tells me it's a two-tailed test. Okay, so now I know it's a two-tailed test right off the bat. Can I even run the z-test here? Well, what do? N's got to be greater than or equal to 30, or it's got to be population normally distributed. We don't know anything about the population, but we do have a sample of 500. That's N equal to 500. I think that's greater than or equal to 30 CLT. All right, now we can drive the Ferrari. N equal to 500. Next one, X bar 13,795. Sigma. Why is it sigma? It says population standard deviation equals 2875. And then alpha 0.1. Okay? So let's use that information to get it. Sample, or the standardized test statistic, X bar minus mu over sigma divided by square root of n. This is 13,795 minus 5. I'm sorry, not 500. What's mu? Mu here, the claim, is 14,050 over sigma 2875 divided by square root of n. Square root of n, that's 500. Okay, type this all in your calculator, put parentheses and divide. Okay, do we need to do that? Let me show you how that works in a calculator. So let me show you how this works in a calculator, just to make sure we're all on the same page when we divide. We don't mess this up. Parentheses, 13,795 minus 14,050, close parentheses, divide, parentheses, 2875 divided by square root second, and then hit the squared button, and then 500. Oops, 500. Okay, and then close parentheses and hit enter. And you get negative 1.983. Now, if you round to 2 decimals, that's negative 1.98. Why do I round to 2 decimals? I've got to look this number up in my chart. Go look it up in the chart. So what's the chart say? I've got my pretty picture here. What's in the middle? 0. Negative z score is over here, so z is negative 1.98. It is a two-tailed test, so what's that tell me? I have one on the negative side. I also have one on the positive side, 1.98. Okay, so area as extreme or more extreme. So I need to find this probability. If you go look up the p-value that associates with this, so half the p-value is over here, and half the p-value is over there. So what is this going to be? This is going to give us, oh my goodness. All right. Now, this is how we would work the problem with p-values, okay? So I'll go ahead and work it through with p-values just because I started doing it like this, but I want to show you how to do it with the rejection region, which is that last part there. So with the p-value, so negative 1.98, so negative 1.98 looks like 0.239. So 0.239. So 0.239. So that means there's 0.0239 over here. So how much total is that? That's 0.0239 times 2, which is 0.478. So the p-value is 0.478, I think is what I said. Okay. Now, the alpha for this particular problem was a 10% alpha. Compared with an alpha of 10%, I'm pretty sure the p is small. P is less than alpha, therefore reject the hoe. Small p, the null must go. Okay? But here's what I want to do. I want to show you how to use rejection regions, because the last thing we talked about in the lesson were the rejection regions here. Okay? So with the rejection region, instead of looking at the p-value, we're given some critical z-score, okay? And what we're saying is if I fall in an area that is more extreme than that critical value, then I'm in the rejection region, okay? So like for a two-tailed test, like in the middle here, we're okay. We're going to fail to reject. That's the non-rejection region. But if I fall out here or I fall over here, I get a z-score over there, then I'm going to reject that thing, okay? Reject the hoe. And so what is the value here? So if I find a z-score, now alpha is equal to 0.1. This tells me the critical value z naught. This tells me the critical value C naught. So you're going to be asked to find the critical value on the test. So you need to know how to do this. So the critical value with a two-tailed test, okay? If alpha is 0.1 and it's a two-tailed test, 10%, 5% is over here and 5% is over here. So the number you have to go look up is 0.0500. But guess what? This is that special one that if you go look it up, you won't find it. So the critical value is negative 1.645. Okay, remember you average negative 1.64 and negative 1.65 together because it's right around this value here. And then the positive, what's in the middle, 0, is 1.645. Okay, so the rejection region is any z that's less than negative z naught, or any z that's greater than positive z naught. Okay, then I would reject. Okay, so when I look at this z-score that I've been given here, all right, how does that relate to my critical value here? This is a z naught of negative 1.645. So anything to the left here gets rejected. Guess what? This blue z equal to negative 1.6 or 1.98 is less than the green z naught, negative 1.645. Remember, numbers on the right side are bigger than numbers on the left side, right? Okay. So therefore, what does this tell me? I reject H naught, okay? So my critical region would be reject anything that falls in this region or this region. It turns out that our test statistic When I look over here, our test statistic fell in somewhere right in here. So that's the rejection region. That's why we reject the hoe, okay? So that tells us to reject, all right? So on your test, you're going to be asked to write, what's your decision? I reject H naught. Why do you reject H naught? The z-score I found is less than that negative z naught that's right here, okay? The z-score I found is less than that. If you want to write the z-score is less than the negative 1.645, because that's the cutoff point right here, I'm okay with that. Okay, if writing the number is better than the z naught, that's fine. So what's the conclusion? If I reject, I say, there is enough evidence. Is for reject H naught. That's what reject H naught tells me. If it's failed to reject, I put is not. All right. So there is enough evidence at the alpha equal to 0.1 to reject. Why do I say reject? Because the hoe is the claim. Only thing I can do with the hoe is reject. The claim. What's the claim? That the mean annual cost of raising a child to or under by married couples in the U.S. is 14,050. Okay? So there is enough evidence to reject that claim. All right? We went out, we asked a lot of people, we asked 500, and we came back with this information right here. It's a little bit less is what it looks like, okay, based off of the sample that we went out and chose. Okay, guys, that ends 7.2 examples.